Today we're going to talk about samples and really about cases, variables, and measurements within samples. All right, so we need to talk about samples because statistics is all about data, and data is made up of cases, right? So each individual that is part of that data set is called a case. And cases are actually made up of variables. You could think of variables as different characteristics within a case. And a variable can take on different values, right? So just to give you an example, here's a data set that's really simple. We have 3 cases, right? 3 shapes, right? And they have different variables. You could think of these almost as dimensions, right? So dimensions of shape, color, area, right? And so these variables right up here these can actually have different values. For instance, triangle is the value for this case, for this variable of shape. For this case, square is the value for the variable of shape. And circle is the value for the variable shape for this case, right? So a variable can take on different values. And because of that, it's called a variable because it could vary, right? Now, it doesn't have to vary. For instance, take a look at color right here. This is a variable that has all of the same values, teal, 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 right? And so although they don't have to, in a variable, the values don't have to vary, they can, right? So we could put a red case in there and it's okay. All right, one thing to note is that regardless of data sets, oftentimes you'll see cases listed in rows. So often each row is a case. Also, often each column is a variable. And you'll learn about different kinds of variables as we go on. So when you look at columns, you see variables. When you look at entire rows, you see cases. Not only that, but when you look at a cell is a combination of a particular row and a particular column. When you look at a cell, that cell often contains a value. So sort of next to cases, variables, and values, as a small note about where they might be in space, you might say usually in rows. This one is usually in columns. And values are usually in cells. Now, this doesn't always have to be the case, but usually by convention, many data sets are organized like this. So we could look here. Here, the cases seem to be made up of individuals. Here, the individuals are taken from Facebook. And the variables are things like gender, friends, siblings, and number of tagged photos. Now, tagged photos by itself is a variable. It could vary. There's lots of different values that it could hold. For instance, 24, 142, 21. So these are different values that could be sort of sitting in the place of the variable tagged photo. So just to give you one more example, here's an example of aircrafts. So these cases are aircrafts. And on each row, there's information for this particular aircraft on that row. The different variables here are number of seats, the cargo that it can carry in tons, and let's say average flying speed. So here we could see that the B747 has 410 seats as the value for the variable number of seats. And once again, it's organized rows being cases, columns being variables, and cells being values. Now, I want to introduce one other idea. Remember I said that variables can have different values. They don't have to differ, but they can. There are some characteristics that will not vary, though, because of the particular design of the study. For instance, maybe a study would like to look at pregnant women and how much prenatal exercise they do, and whether that predicts the health of their baby. Well, because of the design of this study, the gender, the variable gender, is actually not going to be a variable because there are very few men doing prenatal exercises because they're pregnant, right? Instead, this is what's going to be called a constant because the values are all the same by design. Okay, now the question is, great, we know how to organize the data once we get it, but how do we actually get that data? Well, getting data, the process of getting new data is called research. And often research is taught with the 5 scientific steps, asking a question, coming up with a hypothesis, coming up with a design, research analysis, as well as coming up with a conclusion that sort of addresses that question. Now, in order to sort of reframe this scientific, the 5 steps of science, so that it relates more to statistics, I'm going to talk about these things in terms of variables and cases, because that's what's involved in statistics. So research will be about how to get the sample, right? So already we are putting in our statistics terms, how to get the sample. The research question is often a proposed relationship among variables. And a hypothesis often goes with that. So it says, yes, I do think this is the relationship, or I think there's another relationship, right? So these often go together. The research design is the procedure that we use for actually collecting the data. And measurement is actually the process for gathering quantitative information that represents some variable or variables. Let's say the quantitative values, just to use those same words, values that represent or variables. Okay. So here, we're talking about how to actually get the sample. We're looking at proposed relationships among variables within those cases. So research design is all about the procedure for actually collecting that data. Measurement is about gathering quantitative values that represent some variables, right? And research analysis is what we often think of when we think of statistical analysis. So I put statistics right here. And here in statistics, statistical analysis is going to have its own statistical question and hypothesis. It's also going to have statistical procedures. And you're going to be able to come up with a statistical conclusion. Often this little mini set is often called hypothesis testing. We'll get to that when we talk about inferential statistics towards the middle and latter end of the course. And finally, the research conclusion is going to be different than the statistical conclusion. Here in the research conclusion, we step out again and go back to how this analysis relates to this overall research question, right? So this is the general conclusion. And this general conclusion is created from the statistical conclusion, as well as, considering sort of all that came ahead of you. All right, so what kinds of variables are there? If our research question and our hypotheses are all going to be made up of variables, we better try to figure out, hey, what kind of variables could there be? Well, there's a couple of different variables that you need to know. One we already covered. This one is not really a variable. It's sort of right outside the border of variable, but it's related. A constant is a characteristic that cannot vary in the data set. So for whatever reason, it cannot vary. But other than that, there are two kinds of variables you need to know. One is discrete variables. And when we talk about discreteness, we're talking about things that have very particular values. So when you think about a number line, there are only certain places that can contribute a value to a discrete variable. So these are the only values sort of allowed in a discrete variable. So examples might be something like number of siblings. You may wish you had only 1.5 siblings, but that's actually not possible, usually. So number of siblings is what we think of as a discrete variable. You either have 1 or 2. You rarely have 1.65 or 1.82 number of siblings. Also, another example might be number of gold medals. 1 in the Olympics. So often people don't win just half a medal or 1/8 of a medal or 5 2/6 of a medal. Instead, they win whole medals. So there's only particular places on the number line that can contribute values to these variables. So these are examples of discrete variables. Continuous variables are sort of exactly the opposite. So we might have these, whole numbers like 1, 2, 3, 4, but when you have a continuous variable, you could have this be the value, or you could have this be the value, or the one right next to it as the value, or over here as the value. Any of these values can contribute to the variable. So one way you might want to think of this is that there are no gaps on the scale. So any value can contribute, can be part of this variable. In discrete variables, only certain values can take part in this variable. So examples of continuous variables, are things like length, weight, right? These are values that could have any number. So it doesn't have to be 100 or 101. It could be 100.1 or 100.001 or 100.0001, right? So there is an infinite, even between, let's say, 0 and 1, there's an infinite number of values that could contribute to a continuous variable, such as length or weight. Other possibilities are more abstract. Things like anxiety level or knowledge of history, right? Because somebody could be maybe right here in terms of anxiety level, but someone else could be very close, but just a smidge less anxious than them, right? So these are what are thought of as continuous variables because any value is actually possible.